Welcome to Black Hat. This is the Palace 2 Ballroom, and this is a talk about Universal DDoS Mitigation Bypass. Thank you for coming.
Good afternoon, ladies and gentlemen. I'm Tony Miu. Today we will present you the fruit of our research, Universal DDoS Mitigation Bypass. Before we start the presentation, let me ask you, how secure is your network against DDoS? If you think you are secure enough, where does your confidence come from? Just because you passed an audit from a big firms, or you spend a lot of money on expensive solutions? We are about to show you something that will make you think again. For the past 10 years, I've doing network security research and is now working in NetSecGuard as a network engineer. We are doing the next generation DDoS protection with a bunch of highly talented people. Working at the front end of the battlefield, I dealt with the real-world network threats on a daily basis. Over the years, I have observed that the DDoS landscape is start to changing, become so advanced. Now, they are harder to detect, harder to mitigate. Even in the past, they are focusing on how large the attack to attack you. Now, they are focused on efficiency, how to bypass. In the technical terms, we will say that the attack bypassing rate, because the attack now is focused on how to bypass and attack your server directly. In collaboration of anti-ISAC, the Network Threats Information Sharing and Analysis Center, we are developing a tool to evaluate how effective existing DDoS solutions are. In protecting your network, the result was scary. We have been more successful than we expected. With me is Albert from anti-ISAC. Give us a little background about the problems.
Right, thank you, Tony. So essentially, our presentation is divided into several portions. First, just for a little background, in order to form the framework from which we can talk about these commercial solutions and how we bypass them. We look at attack categories, and then we will look at the prevalent a method for DDoS detection and mitigation. We will look at from a high-level perspective the way they work and how they can be bypassed or otherwise taken advantage of in order to cause more damage, so to speak. And then a major part of our research is the development of a POC tool that bring together, all our bypass mechanism under one roof. Now, as they say, the whole is bigger than the sum of its parts. The firepower of our POC tool comes actually from having all our attacks working together. So we would look at how this POC tool works, the mechanism, the technique that it employs. We look at how to efficiently use our tool to execute an attack that can bypass all existing commercial DDoS mechanism. And then we look at the capability of this POC tool. Of course, I mean, offense is just one part of the big picture. Now that we have exposed these kind of weaknesses in commercial solutions, we also conclude with a projection into the future about how the weaknesses that we expose can be adequately addressed. Now, just a little background about how serious this DDoS problem is. Of course, DDoS has been with us for a number of years. These days, the magnitude of the DDoS problem has increased by leaps and bounds. According to a recent survey from a leading telco, these days an average DDoS attack, the attack volume can easily exceed 20 gigabit per second. And on the whole, there are more than 2.5 million DDoS attacks observed per year. What's more serious is nowadays the DDoS attack, they are no longer your old school, Smurf, teardrop, but rather the DDoS attacks of today are getting a lot more complex, sophisticated, that go directly to your upper layer, even into your application to look at specific implementation issues and try to attack from the application level. And of course, according to statistics, these sophisticated attacks actually account for more than 30% of all the attacks that were observed in the wild. So all these means that on average for a specific target, it can cause, the downtime can cost this target up to easily exceeding $6 million per hour. So we can all understand how serious this problem is. And of course, there have been commercial solutions that try to address this problem. And in due course, we will show you how they work and the inherent weaknesses in all these solutions. So let me pass it back to Tony to give us a little background about these solutions.
Thank you, Albert. First, I would like to introduce those of attacks known today. The first one, volumetric attack, like a barbarian, violent, powerful, and forceful. Volumetric attack, it is considered as old-fashioned, but still work in most of the situations. Because he's large, he attacks your bandwidth. We have two kinds of the volumetric attack. The first, packet rate based. Packet rate based is focused on how many packets they are sending to attack you. In other terms, packet per second. For the bit rate base, it's talking about how large of the attack traffic is attacking you. Yes, it's the attack size. Both of them can be TCP, UDP, ICMP, even any other protocol, because the attacker, they are focusing on the efficiency to generating the attack size. Because volumetric attack means the attack is killing your bandwidth, how large they are. However, as we probably tell, the DDoS attack have been changing. Just what Albert mentioned, it's become more complex. It is because most of the devices today have no problem handling the DDoS attack, especially the volumetric attack. Because this one is the base one. If you cannot handle that, means, you fail. So that's why the majority of the attack now is focused on layer 7. Another type of the attack, semantic attack. Silently, but deftly. Like a ninja, they carefully studying enemy's move and weak spot before he attack. In the early stage, the attacker will attack the weakness of the protocol. For example, using SYNFUG, it is attacking TCP protocol. Following that, the attacker starts to attack the weakness of HTTP, even the web service. For example, GetFUD or rather slow loris attack. It is the focusing attacking the HTTP protocol that exploit your resources. Like the Apache killer, they are much more clever and smart because they try to attack your web service. Today, attacks are more damaging because they are now target the weakness of application level. Just like your API, you never believe API still can, the people can DDoS your API. The common one is the database. Just the attacker send multiple of the queries to your database and kill your database server. Because the target now, those of the complex attack, they try to as soon as possible to exhaust your resources in your servers. However, those of attack I just explained have identified because they all have the signature, they have the pattern, we can find it. So in our real environment, the third and last kind of the attack I wanted to talking about bandit attack, not just the girdle. The idea of the bandit attack is to hide a complex attack in another DDoS attack. Sometimes the DDoS is not trying to attack you. They want to hidden something. For example, an attacker, he generates 10 gig sync fuck. Yes, 10 gig sync fuck. Your mitigation provider told you, hey, I detect it, I block it. However, your system still crash. If you try to check in your system, nothing fun. Your traffic is normal. Your connection is normal. Even your access log is normal, nothing to see it. Until you try to conduct a detailed report to analysis, you will find that just a 1 megabit per second as the layer 7 attack, it's crashed your server. Yes, the 1 megabit per second is 100 times. This kind of the bandit attack now is very common. Why? Because it's very effective. Because this kind of the attack, they can hidden and attack you sequentially and just kill you. Now let's us have a full picture to know what they are matching. This matrix is summarized the characteristic of value matching attack and semantic attack. The x-axis represents the attack's complexity, and the y-axis represents the attack size. As you can see, value matching attacks are simple but huge, and semantic attacks are small but highly complex. So where is the bandit attack? Bandit attack is a combination of those two attacks. There are a few ways we can mitigate those attacks. For the simple but huge attack, we can use traffic policing to mitigate those attacks. When attacks become more complex, we can start to implement black and white lists. And when attacks become more even complex, once we can start to carry out is proactive resources. I will quickly explain the different mitigation techniques in here in the next 3 slides. Traffic policing involves set up a rules to allow or block or very limit the traffic based on their type. In our example, we are using the traffic policing to limit the traffic rate. On the other hand, it also can limit how many TCP sync, how many TCP sync add, how many TCP push add. In other terms, we can use the TCP to limit other protocols, just like HTTP. In proactive resource releases, it means you monitor and release the idle and slow TCP connection. In an example of slow low-risk attack, the botnet will keep a lot of the TCP connection alive. When your server's connection pool is staffed, you have risk at rejecting any new connections. At this time, your mitigation service is able to detect the idle and slow TCP connection and send a reset and close it. Black and white listing. It is all about maintaining a list of IP address to drop or allow based on traffic flow of source IP. So far, the mitigation technique is due to the attack traffic has already reached us, which is great to stop the attack at the source. Anti-source isolation. These have been research prototypes try to make it possible to get the network from which attack can come from to drop the attack. One such example is the stop it system. Stop it server try to deploy an AS network, take requests from system under the attack and figure out where the source AS network is for the request to the AS networks to stop it the server, which then introduce the source router to block out the attack traffic. There are also solutions that distribute huge traffic problem because you stop the traffic in the beginning, the attack traffic. So we cannot send a huge traffic across the network anymore. One of another solution, we can distribute the huge traffic is CDN, Content Delivering Network. It is custom of the server to deploy to accelerate web performance by different methods like caching. When client he send a request, it will redirect to the nearest server, also the shortest path. This kind of mechanism also can try to distribute the attack traffic, I mean the huge attack traffic. At the same time, the CDN will distribute the return traffic, because the return traffic we are talking about is 10 times, 100 times, even 1,000 times of the incoming traffic. If you don't distribute it well, that means your traffic will congestion. However, CDN still have the weakness. It's resistant to the layer 7 attack. It's well known. You can use the different HTTP protocol to bypass the CDN. Give example, we can use query string. Query string is just a question mark. After that is some random code. This one, because to the CDN, they will think that it's a new request. As a result, the CDN will think that, oh, it's a new request, so we pass it. In other terms, because you will have to access any traffic come from the CDN's IP address, that means any attack that bypass the CDN will hit your servers. And those attacks will harder to analyze because the CDN will rewrite your HTTP layer. As a result, you're harder to analyze and harder to find the patterns. Another possible is that the attacker can directly attack the back end. How the attacker know your back end? Maybe they use the scanning tools, just like something IP resolve you can find in the Google. Maybe they use the social engineering. Maybe they use the business spy, because too many possible can be listed. However, the most important aspect of mitigation starts with detection. Because if you cannot detect the attack, that means you cannot mitigate the attack. To detect those attacks, we use few methods we saw on the slide here. Rate measurement and baselining can be used to detect the volumetric attack. Portal sanities and behavior tracking can be detected semantic attack, but it's partly. With the use of big data, we can combine those detection methods to help us and identify a potential bad attack. However, because attackers today now are getting more complex and attackers are getting more intelligent, they're able to design the attack to bypass those mitigation and detection. In the following slide, we'll go through the weakness of each of the detection. For rate limit, and for the rate-based and flow-based kind of measure, we can detect the attack based on the source IP, destination IP, HTTP request, even the TCP thread. Most of the volumetric attack can be detected in this way. However, botnet are usually well distributed over the world. The number of the bot attacking you will count about a few hundred thousands. For example, each of the bot, he only sends 10K bits per second. Your countermeasure never trigger. As a result, if we need to detect them, we need to base on the protocol tracking. To detect protocol-based attack, we will have to identify the signature in the attack. For example, Apache Kira, the HTTP field is extra long. In this case, we can use protocol pattern matching to drop it easily. However, attacker now, we try to learn your traffic behavior. They have a capacity to duplicate all your traffic pattern and behavior. So the result is that you cannot identify which is attack traffic, which is normal traffic. Because the pattern is the same, it means if you drop the attack traffic, you also will drop the normal traffic. So nothing to do. Actually, all the detection, we will not working individually. We will combine together in order to have a chance to detect a bad attack or any attack. Band countermeasure, which means we will combine all the detection together and do the traffic statistic and behavior big data analysis. Give you an example. Your website is a supermarket delivering service. It's only serving Las Vegas only. One day, all the source IP over the road is trying to access your website. Yes, all the traffic are over the road. And the interesting thing is that all their traffic rate is similar. It's around 10 kb per second. Based on your protocol tracking, you cannot find any pattern. It's nothing abnormal in this case. But if you try to see their user agent, something is very interesting. They all is use Windows XP. They all is use Firefox. Even the plugin also is the same. That's how we use the big data try to analyze it. Because all the data show us it's not human being. It is example of how we use the big data to detect the attack. In this case, the key is geolocation source IP, the similar traffic rate, and user agent. When we combine all the data together and use the statistic, we can find the abnormal pattern. I mean, we can find the abnormal pattern inside the normal pattern. Because the attack now is all we will use the normal pattern. But this was 2 years ago. Today's attacks are no longer so simple. It has become more complex. The attacker nowadays, they will at least to know how to randomize their user agent. And they will change the pattern every day, even every 15 minutes. At the same time, big data analysis have its challenge. Big data analysis makes sense. It is for the prevention because it's doing post-attack analysis. If we want to do the real time, that means you need to do it in the DDoS environment. In the DDoS environment, the attack size is talking about 60 gig per second, 100 gig per second. That means you need to gather the huge traffic, the huge data. In the huge data, you need to find the necessary data and correct data. So after that, you need to analyze it in the real time because attacks usually happen in your peak hour. So you need to gather the correct data, analyze it with the signature, detect it again, and mitigate it. And do it again if the thing, and do all the things in a short period. If they change the pattern, you need to do it again. Real-time analysis is possible, it's never hard to change. On the other hand, some vendors and field sources, they will providing malicious source intelligence. They will give you the source IP confirmed have problem and reported. However, most botnet use DHCP, so the IP will change. So the fixed IP you can brought in the botnet, that means just a little, so it's not used. So that means all the detection or mitigation is not working anymore. Lastly, and most important, we have is the source host verification, which is currently the most accurate and effective method to mitigate those volumetric, semantic, and band attack. And it is done automatically. Use different approach that was developed further to compare with the evolution of the botnet as well. We have TCP sync, HTTP redirect, HTTP cookies, and JavaScript, and capture. For the TCP sync authentications, the design is to mitigate the TCP sync flood. It will verify your client is non-spoofed source IP or not, but both on that now is the real host. That means you cannot stop it. It still can bypass it. So we do it on the layer 7. HTTP redirect and HTTP cookies. They will try to verify HTTP compliant application. That means you will try to, if your browser, you are using the program, you cannot pass it. However, just like a simple program like curl, wget also can do it. If you add a little extra program, we also can bypass the cookies authentication. So attacker just write a simple program, they can bypass it. A part of the continuous development in layer 7 attack mitigation, the JavaScript authentication was created to address the limitation of the bonnet they does not support JavaScript. This time, they will verify you are using the real browser or not. However, JavaScript is a client-side programming. That means you can download it. After that, you can analyze it and simulate the traffic flow and bypass it automatically. Lastly, we have the capture authentication. This type of authentication is designed to interrupt the request by having user interactive. Before the request can be allowed, a user will manually input some characters to establishing a connection. This method is found to be very effective, but poor user experience, because sometimes you also too difficult to understand what's that. This authentication is very challenging since algorithm analysis and engineering of the capture function will really take a lot of time. Before it can be successfully done, source host verification is most important countermeasure currency. If I tell you, if a tool can bypass all the detection, mitigation I told you before, also they can bypass the source host authentication and confuse the big data and bypass it and do it automatically. Albert will explain our tool, kill them all.
Thank you, Tony. Thanks for staying with us. You won't be disappointed. Behind this rather powerful push-button script PD tool lies years of research behind it. Now, given the rather comprehensive history lesson on DDoS attacks, you might notice that at the top layer these days, the source host verification stand, as a class of its own, as a means that to filter out the non-human, possibly zombie attack sources and block them once and for all. And then there were the more traditional preemptive protection mechanism like rate limiting and protocol anomaly analysis. Those happen after the source host authentication. So essentially, you can visualize our attack tool in two paths. So on the left-hand side, you see there are a number of options for bypassing various authentication mechanisms, and then on the right-hand side, you would see tunable parameters that were designed to allow you to tune the post-authentication traffic so that it would go under the radar of all these, traffic shaping, protocol, behavior, anomaly rules. So we would talk about individual options in depth later on, but let me give you an overview of a strength of our POC to affectionately call kill them all. As its name suggests, kill them all can kill all existing commercial DDoS protection solutions. And I guess one of its major strengths come from its use of true TCP stack. Because as you can imagine, like mechanisms like TCP authentication relies on probing, the source for proper behavior. If you're a zombie, you probably would not behave like a normal TCP stack. Our tool got a real TCP stack, so any attempt in verifying that, our tool will just pass with flying color. And then we've got believable HTTP headers. I guess a number of DDoS programs out there, they kind of make a mistake of having repeatable patterns, identifiable signatures. We try to randomize those identifiable patterns to make it look real and difficult to detect. Another major portion of our tool is an embedded JavaScript engine. So any attempt in verifying the source for proper JavaScript interpretation capability. By and large, our tool would be able to pass that test also. What's actually more interesting is we actually spend the effort in putting in CAPTCHA solving capability. Of course, I mean, the capture is a lot more like an arms race, but we have demonstrated our effectiveness in bypassing some of the lower forms of CAPTCHA. And as I mentioned, other than believable headers, we also got randomized payload, so as to make the job of writing filters a lot more difficult. And I also mentioned we got tunable traffic model where you can tune the post-authentication traffic to bypass whatever heuristics with regard to traffic behavior you observe in your target. So without further ado, let me pass back to Dr. Lee to give an overview of the individual detailed implementation. Dr. Lee.
Thank you, Albert. What these two strings make the tools indistinguishable from human. How can we achieve that? We have different authentication bypass module implemented to bypass the source host authentication part of the mitigation system. This part, we will talk more about technical details in DEFCON, and you might see the mechanism in our white paper as well. What we want to emphasize is this one, the CAPTCHA module. As you can see, and in the coming video demo, this screenshot capture the bypass traffic that attack directly to the backend server through a CDN. You can see that should be through a mitigation device. You can see that the mitigation device pass a CAPTCHA, I mean this one, to the user, and our CAPTCHA engine can recognize it, and then pass the authentication, and then carry out the post attack. The details of this parameter tuning, we will also talk about in DEFCON. Let me quickly go through it and directly go to the video that you might be interested. Let me describe the testing environment first. We have a mitigation device in between our testing machine and the backend server. And the left part is the client side. You can see the client side launch our POC tool, kill them all, and also the Wireshark, the packet capture. On the server side, we have also have a Wireshark opened to capture any traffic received, and also we have a web server log here. So let's see what happened. When we start the button, when we start the attack, actually it just performed the CAPTCHA authentication. You can see the traffic go to the you can see the traffic. The mitigation device return a bitmap, which is the capture image. As we described before, we have several attempts to perform the authentication to increase the success rate. The backend server received the successful authentications. What next? Is after authentication, the mitigation device will put our source IP address into the whitelist. And as you can see, we launched 4 HTTP requests, and this is the first one. Remember the randomized HTTP query? The second one. As you can see from the server side, these HTTP attack goes to the backend directly, and also this can also be reflected in the server log. Let us examine one of the TCP stream. This is the one that I captured in a screenshot previously. So these two first will successfully authenticate itself and also successfully launch attack directly to the back-end server. Don't say that I won't warn you. This tool is just purely for education and research purpose. If you launch it for the real attack, we can't save you from jail. How can we achieve that? Is that in fact, because we want a POC tool to be lightweight and also can be applied in the botnet environment, so we just implement a very, very simple capture engine for this tool. We first convert the image to a black and white image, and then also apply median filter to filter out the noise. Next, we segment the word into characters and then recognize the boundary. And finally, we compute the pixel difference against our library. This library is also included in the tool given to you, which should be downloaded from Red Hat website, right?
Yeah.
Okay. So our testing environment shows that just maybe because of time constraint, actually besides the capture, we also have JavaScript bypass. We also have HTTP redirect bypass and HTTP cookie bypass. And this is the testing environment. If we test a mitigation device, we have a mitigation device in between the backend server and the client computer. If we are testing the cloud, I mean the secure CDN environment, we have a backend server protected by a CDN, and then a client attack the backend server. Here are the results of different bypass, and you may see that it is quite impressive. And the details can also be found in the paper, in our white paper. So does it mean we don't have any way or we don't have any solution?
Of course, we would, in light of this bypassing technology, we think hard about how the underlying DDoS protection problem can be resolved. So if you look at the existing solutions, a lot of the weaknesses stem from a misguided attempt in the distinguishing zombies from a real, legit network client. It can go as far as trying to determine whether a real human is sitting behind the computer. Of course, I mean, if you go so far as to block out all the supposedly zombie without a human behind it, you also sacrifice the interoperability with automated web clients. So, like other capabilities like verifying for JavaScript, verifying for proper behavior on the TCP/IP stack, I would think that those mechanisms were kind of misguided because these capabilities can always be emulated, and our tool essentially demonstrated how easy it is to bypass these authentication mechanism by mimicking what a real client would do. So rather than trying to outright, block out all the non-human, non-properly behaving client from your traffic mix, why don't we go the other way, the other route, which is to actually delay clients from accessing our server, and we can do it with a blanket attempt by using client puzzle. It works like Bitcoin, so it doesn't really matter that you can buy botnet easily to execute your attack because the underlying economics has changed. With the introduction of client puzzle, the attacker now has to deal with an increased cost. I guess, working at the economics level, it's going to solve quite a number of problems that pure technical solution cannot solve alone. And the implementation of client puzzle specifically address this part by bringing, so to speak, the DDoS attack back into the ice age, where you actually have to pay for this extra botnet. So the cost to cause damage is now a lot more expensive, and we think that it could strike back the balance between the bad guys and us good guys. Now, to wrap up, we essentially illustrated the DDoS problem, how expensive it is to business, how they evolve over the years, and how over the years protection mechanism has also evolved. But we also look at all these protection mechanisms that were evolved over the years. We see how insufficient they are in protecting your network because a lot of them were based on a misguided assumption. So we put together this POC tool that demonstrated the weaknesses inherent in all these existing DDoS protection mechanism. And to wrap it up, we relook at the underlying dynamics between the attacker and the defender, and we propose that rather than trying to distinguish, non-human from real human, why don't we put in, additional costs in the clients? So I guess this concludes our presentation. So thanks for your time, and these are our contact information should you need more information with regard to our research. Now we come from NexusGuard DDoS Mitigation Lab and the anti-ISAC, which is an organization for sharing information to advance the state-of-the-art in network protection. So thanks for your time. This concludes our presentation. Is there any question?
Do you have any ideas around how to implement a client challenge? You mentioned that would be the ultimate solution. Do you have any ideas about how to do that?
Right. The client puzzle has actually been with the academia for a number of years, more than 10 years. Of course, back before the the network landscape wasn't like what it was today. Like back before, you got 7 layers. Now everything is stuffed inside the web layer. And of course, nowadays you got to work with IPv6 also. So I guess my answer is there have been workable implementations already. And as for the actual algorithm, I guess this much is a technicality because they have already been mathematically proven workable algorithm for this regard. So I guess the remaining problem is a bit like the devil's is in the detail, of course. But we believe that with proper tricking, those systems that has worked before on TCP/IP stack can be retrofitted into web client server architecture. And of course, there are other considerations like in our paper, we cited an early research from Princeton and RSA. Back then, their implementation actually has to put an agent in the client. Of course, it's not going to work on a wide scale, but with proper, like HTTP magic, you can actually make it a lot more portable. I hope that addressed your question. Thank you. So you mean spoofing of IP address? You mean yes? Source IP.
Yes, at this moment, our POC tools does not support spoof the source IP because we know the impact of these two coming out, and so we intentionally hide this feature.
Actually, if you go DEFCON, I will explain to you. I have a rate to bypass 30% of the server to attack your device. To bypass the mitigation platforms. I will show you the method. Because the mechanism have the weakness. They will use something like reset, the first reset from the client, or reset you from the when I send the reset from the client, or reset you from the client to the server. I mean the mitigation device, so they still have the weakness. You can cheat it. The result is that you can bypass it. Give example, how you think about the successful sync mitigation device. Case 1, we send a sync, we put a sync ad, and say add push ad, and then we send a reset. After that, we do the one time of authentication. So we have the 4 times for the traffic. The second time is that we send a sync add, and reset. The result is that, yes, we just use the 3 times, and then we solve the resources. The last time is that I send a sync, and then you already know that, this one is the attack traffic, and then you drop it. But the last one I mentioned is not possible to do it. Many devices, many vendors, they wish to do it, but fail. So they still use the first one and second one I mentioned. The result is that we can bypass it easily. In the future, we will have the add-on module for the spoof IP. Actually, the next project is about the volumetric attack, how it bypass. I wish I can answer your questions.
When you're spoofing IP, you may want to spoof IP. You wouldn't be able to do the bypass because you would have an established key connection. So that won't work.
I'll show you one demo. I'll show you one demo to bypass it. Suppose not showing here. Sorry.
I guess nowadays the DDoS attack and defense is kind of working a new kind of model of thinking, whereas in the old days, spoof IP is a major component in your attack because you can amplify your attack. Right. Yes, Right. I guess the short answer is nowadays you don't actually have to rely on spoofing IP to cause huge damage. Like I said, a lot of application level attacks, the resources that they can starve is a lot more serious than just a TCP stick. Right.
I understand. In fact, I understand your questions and his questions as well. If you are launching a layer 7 attack, if you have a device having the 4 authentication we mentioned, there is no need to spoof the IP, and indeed it can't spoof because you need to complete the three-way handshake. Let me clarify. Because our tools is not just, currently our tools is let the operating system, the TCP IP stack to complete the layer 4 or below. But our tools can actually implement that part, customize the layer 4 or layer 3. We can add that module into our tool. From that point of view, we can include the source IP spoofing feature into our tools. And in fact, after the DEF CON downloaded our source code from the website, you might already find that we have this part commented out in our implementation.
One more.
Short answer is yes, and the long answer is we randomize the HTTP headers, HTTP fields, and also we have randomized the query string. Do you have any supplementary?
Yes. Actually, why we randomize those of the things? Because these ones can be also to confuse the big data analysis, the packet size range. That's why we do it. Give an example, we will do it in the user agents. Because the user agent is much more longer. Another one we will do it, just give an example, the access field. The first one is start/start. The other one is maybe what you access, the language, something like that. We will try to randomize all of them. The first one you need to mention for the user header is the priority. You need to follow it, because if we try to capture the attack traffic, it's randomized. So this another thing we will mention in our tools. We will try to just what I mentioned before, same as the normal pattern. Before you try to attack, you need to learn the normal pattern. Maybe use your browser to open it. You have different browser to open it, and then you use capture, and then you use to analyze. After that, you will know how to analyze. Give example. You open a first page. Maybe the language is nothing. After that, they will set to, oh, maybe I'm from China, and then we come to, it's Chinese, something like that. You need to follow all the pattern. After that, you have the full of the randomized list. Because the path, you also need to, you also need to randomize. Give example, login page, welcome page, and then we go to logout page, something like that. I think I can answer your questions.
I hope that answered your question. Any other question from the audience? If there's no additional question, we thanks for your time, and please remember to fill in the survey form. Thanks, and have a good day.